Welcome back everyone for another presentation. What I'm going to be talking about are the various shapes that steel can come in. And so we've got a nice little illustration for you here. And so what I'm talking about, different shapes of steel. I'm talking about, structural applications, whether it's for manufacturing a building, whether it's bridge work, automotive industry, applications for home. There are so many shapes that steel can come manufactured in, and each shape serves a different purpose, and then also each shape is measured differently. So that's one thing that we need to know as a welder or fabricator, because when we're ordering parts, we need to be able to tell our supervisor the exact size of the material that we need and how much. Or when it comes down to reading a blueprint and knowing what materials we need versus what we have on hand, we need to make sure that we know how to choose and select, or basically identify the right size material in order to get the job done correctly. So with that being said, some of the various shapes include plate, basically plate steel, angle iron, bar, beam, and more. So let's start with the very first one. Let's start with steel bars. Now they come in various different shapes, and I've got an illustration here to show just a few of them. So there's square bar, there's rectangular bar, there's round bar, hexagonal bar, octagonal bar. There's many different shapes, and they all serve different purposes. They can be used in framework, they can be used in housing applications, structural applications. This is a very generally used type of steel. And so when we're measuring them, see here, I've got some examples already. And it can also be used in gates, ornamental work, so on and so forth. So when we're measuring square bar, it's actually relatively simple. The size is what we would typically call the thickness of the square bar. So when we're looking at this example here, the thickness from one side to the other, and then from here to here, so the thickness is what we would call the size. So now when we're writing it down, we're writing it the size by the length. So I gave us an example here, 1 inch by 1 inch by 12 feet. So this is basically saying that this square bar would be 1 inch thick this way, 1 inch thick that way, by 12 feet long. Pretty simple, right? Now there's also flat bar. A lot of people will call this a strip, flat stock, whatever the case may be, but it's called flat bar. And so we've got another image here of various different sizes and finishes. And the way that we measure that is pretty similar to square stock, where we have the thickness is measured two different ways, but we're only calling one of these measurements the thickness, and then the other one we're actually calling the width. And so when we write this down, when we find out what the measurements are, we write that as width by thickness by length. And so for 2 inches, the width being 2 inches, that would be right here. So from this edge to this edge, it would be 2 inches long, or basically 2 inches wide. And then the thickness, so this example is a 1/4 inch thick, and then again by 12 feet long. So from this edge to that edge, it would be 12 feet long. Now there's also round bar. Depending on the size, I've heard people refer to this as rod, round stock, so on and so forth. But essentially it comes down to being solid round bar. I should also note right here that this should not be confused with rebar. Rebar is something completely different. Although it's similar, it's just not going to be included with round bar. And so this is fairly easy. There's only two sizes or two measurements that we need. One of them is the size, or basically the diameter, which is basically from one side to its opposite side at any point around here, because it's a circle, and then the length, and that would be written size and length. The example is 1/2. So from this side to this side, it would be 1/2. The same thing from the top to the bottom would be 1/2. It's just the diameter is going to be 1/2 of an inch. And then the length is going to be 12 feet from this point to that point. It's pretty simple, right? And then hexagonal and octagonal bars, they have a lot of different uses, mainly with like tools. If you think like Allen wrenches, you know, those sort of things, that's basically what these are used for. They're pretty much measured the same. So you got to take one flat side, find its opposite flat side, find the distance between the two, and that's going to be your size. So it's kind of similar to finding the diameter with a round bar, but we're taking one flat side to the other. Same thing with the octagonal, one flat side to the other. The distance in between is the size, and then we're just finding the length. And that's going to be written down size by length. And in this example, 1/2 inch by 12 feet. So it'd be 1/2 inch from one flat to the other. Same thing up here. And then the length, 12 feet. Now there's angle iron. Angle iron is, geez, there's so many different uses for it. It can be used in structural applications. It can be used in applications that have nothing to do with structural integrity. It could be ornamental, frames. You know, I've seen angle iron used for trailer frames. You know, there's a lot of different uses for it. And then I will say that there are two types of angle iron. One is where the legs are equal, so both sides are equal length. And then there's angle iron where one leg or one side might be shorter than the other. So I have included both examples here. And so the top one is where each leg is equal distance to the other. And then the bottom example is where this leg is a little bit longer than that one. And so they're measured basically the same. Where the top one, we would find the leg length by the leg length, by the thickness of the angle iron, by the length. And so the example given here is 2 inches by 2 inches by 1/8 of an inch by 12 feet. So that means that from right here, the heel, to the end of the leg, or the toe, that's going to be 2 inches. Now from the heel to this toe is going to be 2 inches as well. And then the thickness of the angle iron is 1/8 of an inch. And then the length of the entire angle iron itself is going to be 12 feet. Now the same thing goes for the angle iron with unequal leg lengths. You're going to write down one leg length, the other leg length, the thickness, and then the length of the entire piece of angle iron. Then there's steel plate. Again, so many different applications for steel plate. It can be used in building manufacturing. It can be used in bridge work. I've seen this also used in home applications where maybe someone wants a really sturdy door. I've seen steel plate be used to create really heavy-duty barbecues. You know, there's just a lot of different applications for it. I mean, some companies out there even cut pieces of plate to create targets for, you know, shooting practice, things like that. And so I will say this, that there is another shape out there very similar to steel plate, and that is steel sheet. So there is a difference between the two. Plate is anything that is thicker than 3/16. Now this is where there's a little bit of debate. I've worked with a lot of welders and fabricators that say plate is anything that's thicker than 1/8 of an inch. In fact, that basically my whole career has been based off of people telling me that plate is anything that's thicker than 1/8 of an inch. So 1/8 of an inch, or 1/8 of an inch, 3/16 of an inch, around there. If it's thicker than that, it's basically plate steel. And so how we measure this is we find the width, and then we measure the thickness, and then by the length. So typically I've always seen the shorter side is considered the width, and then the longer side is considered the length. And then here we have an example where the width in this case would be 4 feet, the thickness is 1/4 of an inch, and then the length is going to be 6 feet. And so plate plate steel normally comes around this size. It can come a little bit smaller, but not too much smaller. This is basically used for, big projects. And then here we go, sheet steel. Sheet steel is used in, again, very many applications. It's used in home projects. It's used in small structural projects. It's used in, the automobile industry. There's so many different uses for it, especially in welding art or ornamental work. Because sheet steel is thin, it can be worked very easily by hand using simple hand tools. There's just a lot of stuff you can do with sheet steel. And so it's basically the opposite of plate steel, where plate steel is anything that's thicker than 1/8 or 3/16 of an inch. Sheet steel is anything that is thinner than 3/16 of an inch, or some people will say 1/8. It can also be measured in millimeters, and then there's also a third way to measure sheet steel, and that is by gauge. So you probably heard the term 10 gauge steel, 12 gauge, 14, 16. These are different sizes of sheet steel. And it's measured in the exact same way as plate. So typically the shorter side is called the width. The longer side is considered the length, and then of course we have our thickness. So here's an example, 4 feet, 14 gauge sheet steel by 6 feet. Then there's tube steel. Tube steel is very similar to steel bar, except it's hollow. And it comes in square shape, it comes in rectangular shape. So basically, yeah, it's just hollow. It's tube. And so there are a lot of different uses for it. It's used in a lot of framework. I've seen it used, to build the frame for tables, lockers, things of that nature. I've seen it used on trailer assemblies. There's a lot of things that we can really do with it. And so here's a basic way to measure square tubing. It can also be used to measure rectangular tubing, where basically if you were to take one flat side, measure it to the other flat side, that is the width, or in this case it's the top and bottom flats, and then the left and right flats are considered the thickness, and then there's also the wall thickness. So there's two different thicknesses here. Alright, so be careful which one you write down for thickness and which one you consider the wall thickness. There are differences here. So I guess for all intents and purposes, let me go ahead and just disregard thickness, and we'll just say the width by width and then wall thickness. How's that? That sounds a lot better. So when we're measuring it, it's the width by thickness, or what we're saying is width by the wall thickness and then by length. So a very common size for square tubing is 2 by 2. So a lot of times you might hear someone say, give me some 2 by 2 square tubing or 2-inch square tubing. And so basically that's telling us that from one flat to the other, it's 12 inches. And we're going by the outside edge. So kind of similar to outside diameter. Next up is channel. And so it's called channel because that's basically the shape that it has. It looks like a channel has been carved out of a chunk of steel. This is also used in framework. It's used in trailer chassis. I've seen it used in some structural work, actually a lot of structural work. And this is how we measure it. So this is, I know this image is a little bit more detailed, but hang with me. We're going to measure it as depth by the length of the flange, by the weight per foot, by the length. Now the weight per foot is something that's given. You don't really have to calculate this. Your employer should have a chart that tells you, depending on the size of the depth and flange, it's going to weigh this much per foot. So you should just have something that you already have available that you can just slap in there and then just write down the length. So the depth is one way of saying how wide it is. So if we look at the image, the depth is from one side to the other. So it's almost like saying this is the width. So in this case, it's called the depth. So we're going to write down the depth when we measure from this outside edge to this outside edge. And then the flange is basically like the leg for angle iron. So there are two flanges, one right here and one right here. You can, again, consider them the legs. And so we're going to measure from the outside edge over here to the outside edge right here. And so we can say that that's 1 inch. So it would be 2 inches by 1 inch. And then we're going to find the weight per foot on a scale that's already determined. This is not accurate. I just kind of made up this number just to have something here. And then by 12 feet. So 12 feet in length. Steel beams. So steel beams are used very heavily in structural applications. So in building manufacturing, it can be used in some shipbuilding, definitely bridge work. These are used whenever structural integrity is crucial. So if you want to build something that's going to hold up and not come crumbling down whenever a breeze blows or anything like that, this is the stuff you want to use. And there's a couple different types of beams, and they're measured pretty much the same. So if we take the top one versus the bottom one, we can see that there are some differences in the shape, but essentially they're measured the same. So if we take the nominal depth by the weight per foot by length. Now when they say nominal depth, what they're talking about is if we go from the top to the bottom and we measure that, nominal depth means like the approximate depth. So instead of being exactly 4 inches, it could be something realistically like 4 1/16. So it's going to be just a tad bit off, but they say nominal depth, so kind of round it. If it's 4 1/16, just call it 4. And so with the example I have here is 6 inches. So from the top edge to the bottom edge would be 6 inches on paper. Realistically, like I said, it could be 6 inches and 1/16, but you approximate it. You round it to the nearest inch. And then weight by foot. This is something that's already going to be given to you on a chart, so you just slap that in there. So this is, again, not accurate. This is just kind of a place filler as an example. And then the length, of course, from here to here would be 12 feet. Pipe and tubing. So pipe and tubing are used a lot. Pipe is used a lot. I will say that there's a difference between pipe and tubing. Pipe is used to transport liquid or compressed gases or, things of that nature. So if you think of gas lines, pipelines like that are used to transport petroleum products. If you think of compressed gases, that's pretty much what pipe is used for. Tubing is used for all sorts of other things. Oh, actually, another good example for pipe is like exhaust pipe. It's used to transport gas. And they're measured pretty much the same. There is a nominal diameter. And so nominal diameter, again, is like if we were to say there's a 3-inch diameter, but you actually measure the pipe or tube, it could be a little off. Could be a little under 3 inches, could be a little over 3 inches, but you round to the nearest size. And then there's also the thickness of the wall, and then by the length. So with pipe, there's a little bit of a change up. If the pipe is under 12 inches for its outer diameter, we use the outer diameter. So that is the outer edges of the pipe. That is what we're going to measure for the diameter. Now, once that reaches a diameter over 12 inches, we start using the inner diameter. Okay, so it's very important to remember with pipe. If it's 12 inches and under, we use the outer diameter. If it's over 12 inches, we use the inner diameter. So when we're measuring when we're measuring our pipe it's going to be the nominal diameter by the weight or schedule or thickness by the length. And so the weight can be the weight of the pipe itself. The schedule, this also applies to pipe. And then the thickness, this is more like your tubing. So 3 different ways that can be applied to pipe and tubing. So just be aware of what it is that you're using. So nominal diameter, remember, outside diameter, when it's under 12 inches for pipe. If it's over 12 inches for pipe, we use inside diameter. And with tubing, it's always the outside diameter. Then the wall thickness, and then by the length. I will say for schedule charts, there are schedule charts that you can find out there that will give you the nominal diameter for pipe, also the schedule size, and all sorts of that information. But I'm not going to include it here because it would take up a few slides. But it's something that you can just find with a quick Google search. And that's pretty much it. Thank you for watching.